You can observe on the screen the panel of speed control of DC motor by field resistance method. So in the panel you can observe MCB for control on off, 3-point start, voltmeter, ammeter, then speedometer, DC motor, field resistance, variable field resistance, and variable armature resistance. Here armature resistance, variable armature resistance is given to set the voltage at 220, because minimum to run the motor minimum some voltage should be set. So to set 220 we are varying the armature resistance. Field resistance, we to control the speed or to vary the speed, we in this experiment we are varying a field resistance, and we are varying a we are varying a armature resistance to set a voltage supply to the motor. Let me do the connections. So I'll show you how to do connections. So from supply to 3-point starter, from 3-point starter to ammeter, from ammeter to rheostat, from rheostat to motor, from again from 3-point starter to rheostat, from rheostat to motor, from motor to voltmeter, from again voltmeter to rheostat. So I can give a return part to this. So this is the circuit diagram. I will explain you how you should make a connection. I will repeat. From a negative point of a supply, that is B point to P, from Q to ammeter should be series, so Q to L, from L to again that rheostat is in series with the ammeter, then ammeter to D point of a motor, again from armature winding, from R to armature resistance to voltmeter. Voltmeter should be parallel to supply, so we have connected that. So let me check whether circuit is correct or not. So connection is correct. So let me set first minimum sufficient voltage to the motor by varying the armature rheostat. So it is set, so you can see the reading in the voltmeter, that is 220. Now I have the motor, presently the motor is in rest condition, so I have to reduce the field resistance so that motor should start. So I will just so I have varied for 2 points. The current shows 0.2 ampere and the speed is 2340 rpm. You can note it in the observation table, so I will add to the table. So speed, it is in rpm, revolution per minute, and current is in ampere. I will know in a table only numbers will be given. The current in the current column it is in ampere, and speed in a speed column it is in a rpm. So I will decrease the resistance for another point. I will set at 3. Now you can see the speed decreases to 2100 and current increase to 0.3 ampere. As you can observe, the current is increasing, which means that field resistance is increasing. So field current is directly proportional to the flux of a field winding is directly proportional to current. As current goes on increases, the flux in the field winding is also increases, which means that speed will reduce. In the previous reading you can observe at 0.2 ampere current it is 2340. At 0.3 ampere it is reduced to 2100. I will add to the table. Now next I will increase the uh, rheostat. Just I will bit move further and let me check what will be the speed and what is the current. The current is 0.4 and speed reduced to 1930 rpm. I will add to the table. I will further to position 5. Current is 0.5 ampere. Speed is decreases. At 6 it is 1575. At position 7 it is 1480. I will increase so on. You will get number of readings. So I have taken 10 readings. By having these all, you can draw the graph. So the graph look like this. So you can take a printout of this graph. I hope everyone understood this experiment. If you have any queries, don't hesitate. Please raise your questions at, already you know the mail, bpatil022@gmail.com.